We are asked to prove that the square of an odd number is always one more than a multiple of 4. I can define an odd number in algebra as being 2n plus 1, because we know that 2 times any number will always be an even number, and an even number add 1 will always make it odd. As we want to prove that the square in algebra is a power of 2, as we want the square of an odd number, therefore it's going to be 2n plus 1 in brackets to the power 2. If we see something in brackets raised to the power 2, we therefore know we write the bracket out twice, because squared means multiplied by itself. Expanding our double brackets, we know that 2n multiplied by 2n will give us 4n squared. We know that 2n multiplied by positive 1 will give us plus 2n. We know that 1 times 2n will give us plus 2n. And we know that 1 multiplied by 1 is simply 1. Collecting like terms, I've got 4n squared and no other term ending in n squared, so I'm going to write that down. Collecting my single letters of n, I've got 2n plus another 2n. They're like terms as they both end in single n. Well, 2 lots and another 2 lots will simplify to give us plus 4 lots of n, and I've still got plus 1. As we wanted to prove that it's going to be 1 more than a multiple of 4, well, 1 more means I should be left with plus 1 at the end. And as it's a multiple of 4, therefore multiple of 4 means that 4 should be a factor. Looking at my first 2 terms, I can see that I can factorise 4 from my first 2 terms. Factorising at number 4, what do I times 4 to get back to 4n squared? Well, I'm missing n squared. And what do I times 4 to get back to 4n? I'm missing simply plus n. And I've still got the plus 1 here on the outside. Hence, we've proved that the square of an odd number is always 1 more than a multiple of 4, because 4 times anything will be a multiple of 4, and a multiple of 4 add 1 will always be 1 more than a multiple of 4.